Hi students, today we'll be going through pure chemistry macromolecules, GCE O levels, chemistry OEQs. So let's get started with the first question. Which alcohol and acid could react together to form a polyester? So to form a polyester, the alcohol and the acid must have two functional groups to form the ester linkage. So in this example, option B is the correct answer because both the alcohol and also the acid COOH has both two functional group. So with that, it is possible to form multiple ester linkages. With that, they are able to build a long chain, hence polyester. So from the example here, we have nylon, polyethylene, and terylene. Polyethylene wise, right, we'll go through addition. So the type of polymer is addition. And for nylon and also terylene is actually under condensation. So the option would be C. Polyethylene is an addition polymer, while nylon and terylene are condensation polymers. Okay, so next question. Diagram shows the formula of a polymer. Which of the following could be used to make this polymer? So what they want us to find out is actually the monomer of this polymer. So to identify the monomer, you have to identify the repeating unit. So out of all these four examples, one of them is the repeating unit. In this case, what we look for is this part, repeating part, CH2 and CH2. So this is the repeating unit that we are looking for. So the answer would be A. From the structure in the diagram, the repeating unit can be considered as shown. So this is the example, the part that we bracketed previously. Thus, the polymer can be made by addition polymerization of the repeating unit. So this part, right, is actually option A. Next question. So here's a little bit of a story of nylon. So this American researcher chemist in the 1930s researched a new synthetic polymer to replace silk. So this is the formation of polymers. Okay, so he's famous for developing first nylon. So we must know that nylon is actually synthetic polymers. Okay, so the number in the systematic names of each nylon refer to the number of carbon atom, the first number. Then the second one is actually from the dicarboxylic acid, second number. That's why we actually have this 6,6. Then for another example, nylon 510. The 5 is actually from the first one. The 10 is from the dicarboxylic. So that's the difference between the two. This is nylon 6,6, nylon 510. 5 carbon, 10 carbons. Then here there's a 6 carbon, 6 carbon. Okay, so let's move on. So later nylon 6 was invented. This can be made from a single monomer that has an amine group at one end, carboxylic group at the other end. So from here, this is the amine group and this is the carboxylic group. This part is the monomer. After we join up all the repeating unit, it becomes a polymer. Other type of nylon developed later. So all these are different types of nylon. Okay, different types of nylon are used for different purposes. One of the limit to their use is that they cannot be used in contact with solution of strong acid. Why not? because they react slowly with strong acid to form the original monomer. Okay, then some other nylon are related to their melting points. For nylons made from two different monomers, the melting point is affected by the chain length. Okay, so melting point is affected by chain lengths of the diamine and the dicarboxylic acid used to make the nylon. Okay, moving on. So here are some example of the melting point. Okay. Nylons are useful because they are generally unreactive and they can be made into very strong fibers. So examples would be making of clothes, fishing lines, ropes, and even machine parts. So to be suitable for making fiber, the nylon chains must have a relative molecular mass between 10,000 and 20,000. So the length of the molecule gives enough strength, but still flexible enough to be made into fiber. Okay, question. Disposal of used nylon. All types of nylon are difficult to dispose at the end of their usage because they do not biodegrade easily. Do not. Okay, a strain of bacteria was found that break down nylon. Nylon can be disposed by burning at high temperature. So that's how we dispose nylon. Both this method of disposal give off. So this one actually has a carbon footprint. So what is carbon footprint? This is the formula for carbon footprint. The mass of carbon dioxide given off per kilogram of nylon. Carbon emission. Give the structural formula of two products that form when nylon 510 is left in contact with a strong acid. So remember, with strong acid, they slowly react. So these two are the product form. The first product and the second product. When nylon 510 is left in contact with a strong acid. A company wants to use nylon 66 to make fiber. Calculate the minimum number of repeating unit which must be present, actually we want minimum, which must be present in one chain of nylon 66. So based on the information just now, minimum, right, the MR that we need molecular mass, minimum is 10,000. So this part is the number of carbon present. This is the number of hydrogen. This is the nitrogen, and this is the oxygen. So the MR of one repeating unit is 226. So minimum MR is 10,000. We can take 10,000 divided by 226. We'll have 44.2. And we round it up. We need minimum number of repeating unit, 45 of them. So how does the length of the diamine affect? Is that the longer the chain of the diamine used to make the nylon, the longer the chain, the lower the melting point. This is shown by nylon 66. We have a longer chain of diamine, lower melting point. If we were to refer to the table previously in front. Then for the dicarboxylic acid, the longer the chain, the lower the melting point increases and the melting point decreases. Based on the previous table as well, we have to compare the one that has the first number being the same. All three nylons are 6 for the first number, but the second number is different, 6, 10, and 12. So we can see the difference between the length and also the melting point. So from here, we know that the longer the chain, the lower the melting point. Okay, next question. Calculate the carbon footprint of nylon 6. So carbon footprint formula is provided in front. First, you need to find the MR of the repeating unit. Then after that, you need to find the mole. Number of mole of 1 kg of the repeating unit. So mole is mass over MR. Okay. Then number of mole of carbon dioxide formed. So for this carbon footprint of nylon 6, right? is the formula here. You have to take the mole, mR, then you get the mass. Mole equals to mass over mR. We are using this formula. Okay, next question. Next question is about vegetable oil. So vegetable oil that have been used for cooking can be reacted to make biodiesel for fuel. So for this vegetable oil, they are triester with long hydrocarbon chains. Vegetable oil react with methanol. The reaction uses a potassium hydroxide catalyst. So the diagram is shown. Structure of some of the molecule involved in the reaction. Okay, so this part here is actually all the hydrocarbon chain. We have the catalyst here, reactant, and also the product. Okay, so let's see what the question wants. Suggest why vegetable oil are called triester. Okay, so tri means tree. Tree. Okay, so the reason for vegetable oil to be called triester is because each of the molecule contains 3 ester linkages. That's why it's called triester. Okay, next. One molecule of vegetable oil react to form 3 molecules of bio. Suggest the structure of one molecule. Use this to represent the hydrocarbon link. Okay, so for this part, we have to draw it up. It will look like this. One molecule. So why does it look like that? Because previously, all 3 of them are linked up together. After the reaction, they will actually separate. After separating, this part is the part that we have one of the biodiesel molecule. Yeah. So that's all for today.